It's an extraordinary power plant which produces electricity economically simply from hot air. The project was commissioned by the West German Ministry of Research and Technology and built in Spain by the German civil engineers Schlag and Partners. Its design relies on one of the most basic principles, that hot air rises. As the sun heats up the air underneath the collection area, the air seeks and finds the only way upwards and out, through the chimney. And as it does so, it turns a turbine to generate electricity. Simple, but extremely effective. Well, this is what the underneath side of the collector area looks like. 4.4 hectares of plastic material called Tetla, polyvinyl fluoride, which is held in position here by these spreaders like that. You can see them underneath here, pulled down by this heavy weight. And that's to keep everything tight so that it can handle the high winds that are generated, not only by the air flowing through to the chimney, but also in this area generally, winds can get up to around 150 kilometres an hour. During the day, the heat builds up here to around 50 degrees centigrade, and the air starts flowing in continually towards the chimney. But the interesting thing is that it also works at night as well as day, and in cloudy and rainy spells as well, because not only the air, but the ground beneath it is heated up during the day to such a degree that in the nighttime it re-radiates that heat back again, keeping the air warm and flowing inwards towards the chimney all the time. The actual plastic itself is only 0.1 of a millimetre thick, but it's very strong, and although it transmits infrared radiation, it's quite resistant to ultraviolet light, which tends to degrade plastic. And the life of sheets of plastic like this is expected to be about 10 or 12 years. One other quite important point that came out during the initial research program that surprised the builders of the chimney was that instead of a desert developing underneath this collecting area, because of the high temperatures here, they got instead quite luxuriant plant growth underneath because of the greenhouse effect, which produced large quantities of condensation during the night. Well, this is the funnel, as it's known, and it's not much more really than two curved capes made of a polymer-coated fabric, which gives a smooth transition for the air that's coming in from the collecting area outside and going up into the chimney above me here, where you can just see the blades of the turbine turning slowly around. Well, it's switched off at the moment because they're making some adjustments. So if we step in here, you can get a good look up the chimney and see what it's like. And you can see that it's really not much more than just a hollow tube, some 200 metres high and 10 metres in diameter. And in here is the turbine. And it's supported quite independently of the rest of the chimney on this big steel tower here, about 9 metres above me. The four blades can be adjusted while the turbine is running to maintain a constant speed, or an optimum one of about 36 kilometres an hour. This pilot one has generated a maximum of 60 kilowatts, but over a test period it averaged about 30 kilowatts of power output. Not a huge amount, but despite its size, the solar chimney was built in Spain for not much more than $1 million, which means that even the pilot plant is considered an economic proposition. But what the experimental programs run so far seem to indicate is that the bigger the chimney, that is, the higher it is and also the wider the diameter, the greater the efficiency and also the higher the power output it can generate. This solar chimney in Spain has demonstrated that it will be possible in the future to compete on a dollar-for-dollar basis with virtually any other form of power generation, with that one unbeatable advantage that it's got an inexhaustible source of free original energy in the sun.